Alright, hey guys. Hey guys. Alright, today we're going to be doing Earth Science Review. Okay, so we're going to do a simple ABCD kind of thing. I'm just going to go over 4 things with some pictures and everything good, so you can always come to me for all your Earth Science needs. And I just want to say one quick thing, that if you want a longer video on a specific thing, please comment or message me. Subscribe. Okay, so Earth Science Review. A. The real shape of the Earth is an oblate spheroid. So that's the real shape of the Earth. It's not a circle. It's an oblate spheroid. Let's look at an oblate spheroid. This is an oblate spheroid, which is the real shape of the Earth. As you can see, that it bulges out in the equator, and it's flat at the poles. One way that I can always remember what the true shape of the Earth is as an oblate spheroid is imagining me taking a very flexible balloon, blowing it up, and tying it together in place. I then take my 2 hands and put pressure on the top and the bottom and squeeze a little bit and then leave my hands there. That is basically the shape that I'm showing you here. Okay. B. Let's make this big again. The altitude of Polaris equals your latitude. So let's first look at the altitude. So let's read that one more time. The altitude of Polaris equals your latitude. What's altitude? Altitude is the height of an object. Therefore, elevation. So basically, the elevation of Polaris equals your latitude. But what is latitude? Latitude is the measure of relative position, north or south on the Earth's surface. So the elevation of Polaris is equal to your your position on the Earth's surface. So remember, Polaris is the North Star. It never moves. Okay? Polaris never moves at all. And because it doesn't move, Polaris is only special because it is in line with the Earth axis of rotation. So Polaris is with us all the time, our Earth axis rotation. And that's because it never moves. It's always smack there, North Star in the north. So let's move on to gradient. C, gradient. Lines closer together is steep gradient. Lines far apart is a gentle gradient. Now remember, you can find the equation for gradient of something on the first page of your ESRT. ESRT is short for the Earth Science Reference Table. And again, guys, when you are taking a test or the Earth Science Regents or anything, you need to use your Earth Science Reference Table. That ESRT is going to be your BFF, your biffle, your best friend for life. Best friend forever, because it'll help you find the answers to many questions. It's very helpful. So, back to the gradient. Just to review, gradient is equal to change in field value over distance. Let's go to the last one. D, isoline. An isoline is a line connecting points of equal value. I'm gonna show you an example of that. So remember, a line connecting points of equal value. Keywords, equal value. Let's show you an example of this. So January temperature, degrees in Fahrenheit. These are isolines right here. As you can see, back to what we were saying, equal value, 95, it's going all over where the January temperature, the area where it was 95 degrees, it's going over it, and that's equal value. Right where the line is, the black line, that is 95 degrees. And over here is 95 as well. This is 85, this is 75, and this is 65, and this is 85. So as you can see, lines of equal value, the 85 goes over here, and it goes across the water or whatever, and then it comes back to 85. Alright, so guys, I hope this was helpful. And one last thing. is, like I said before, always use your ESRT, which is the Earth Science Reference Table, guys. Because 50%, at least 50% of the answer to any question is available in the Earth Science Reference Table, guys. So always learn your reference table. Learn the 1 through 16 pages of pure information and answers. So I hope this was really helpful. I'm going to be making more videos, so I hope you enjoy them. Okay, bye guys.